Welcome to our next science lesson. We are going to look at the sun in the solar system. Remember, in the previous lessons, we were able to look at the Big Bang Theory, and actually we looked also at the galaxies, we looked at the stars, and the sun being one of the stars, and also the planets. In this session, we are going to look at specifically the sun, and then we move into the solar system. What is the sun? It is good for us to be able to have an understanding of what the sun is. The sun is simply a hot ball of glowing gases, or you can also say that it is the sun is a star which is made up of hydrogen and helium gas. Now, in this context, having understood that the sun is a star which is made up of hydrogen and helium gas, remember, hydrogen and helium gas are in constant reaction that produces what we call nuclear fission at its center, and that is what converts the hydrogen especially into helium, and so it produces the radiant energy that is referred to as the solar energy. And the solar energy is actually very much important. The solar energy is very important. It is the one that makes life very much possible on planet Earth. Without the solar energy or the solar radiation, life could have been impossible on Earth. Remember, every living thing that is found on planet Earth, it is made possible because of the radiation energy that is found or that is emitted by the sun. Also, another aspect you have to understand is that the sun has its own gravitational force or gravitational pull. It is this force of gravity that holds. It is the gravity that holds the solar system together, or the solar system in position. Because it has got its own force of gravity, this gravity is very much important because it is the one that holds the solar system in the position, and that position is the orbit. Just to extrapolate shortly here, you'll be able to have found out that having this gravitational pull, the solar system is kept together in its orbit, and therefore as a result of that, we are going to understand the structure of the sun. The sun is made up of various layers. We are going to look at each of them. But when you look at the interior of the sun carefully, you will find that it has enormous, very high temperatures that are actually approximated. The temperatures are approximated to approximately, and that is about 15 million degrees Celsius when it is in its interior. While you come to the outer surface of the Earth, the temperature is approximated to around 6,000 degrees Celsius. This on the surface of the sun. Therefore, that means there is a mystery around the sun. And actually, this mystery is still, even up to today, being worked. The scientists are hoping one time they will be able to unravel the mystery concerning the temperatures of the sun, being very much curious in such a manner. Now, when basically we look at the structure of the sun is made up of various structures that we'll be able to have found. And one of the part of the structure of the sun is actually, we look at the core. We have the core. The core is the one that is basically made up of helium and hydrogen. Gases is actually basically made up of helium and hydrogen gases. The way you just have been able to understand the structure of the earth, that's now we are also looking at the sun. The sun also has got its structure. And the core is the innermost layer of the sun that comprises of helium and hydrogen gases, which are in constant reaction. Actually, that is nuclear fusion. That is the one that makes this part of the sun to emit solar radiation or the solar energy. In this part, most of the matter is actually densely packed and actually make the sun to have a substantial density of a particular rate. Although it has not been identified up to this time, scientists are still underway to unravel some more part about it. And then after, we also have been able to look at the core, which is made up of helium and hydrogen gas. There is also another part that is referred to as the corona. The corona is the outermost layer of the sun. This is the outermost layer of the sun. The outermost layer of the sun that stretches far into the outer space, and in fact most of its particle or most of the particles of the corona, probably most of them may reach the orbit of the earth. And during the total eclipse, that is the solar eclipse, sometime when you are on Earth's surface, you will be able to see the corona as a thin layer that can be seen by the help of the coronagraph telescope. It cannot just be easily seen by the naked eye, but that one only happens during the solar eclipse. That is the total eclipse of the sun at that particular time. Remember, we had looked at the solar eclipse in different manner. Okay, you'll also be able to have identified out that the shape of the corona is the one is determined by the magnetic field. The shape of the corona is determined out by the magnetic field, field of the sun, where there are free electrons. These free electrons are actually moving along the magnetic field lines from different structure of the earth, where these free electrons, when they are in motion, they are actually reaches a point, they make the sun to glow, either in different color, especially the red one, the red glow. When hydrogen and helium gases are fusing together, you will find that some of the electrons will glow red. That is why the sun's color is mostly almost red, yellow, brilliantly producing some of its light. And that is why you'll be able to find out. Then, the corona is very much important because it emits energy in various wavelengths. This energy are emitted in various wavelengths such as the radio waves. When we looked at the wavelength of the radiation that the corona emits, it emits the radio wave. This is an example of a wavelength. It also emits what you call the X-rays waves. And there are also soft X-rays waves. And remember, where there are X-rays, we also have the other reactions that will be taking place during fusion. And during that, it's actually full of radioactivity. The other rays, such as gamma rays, beta rays, and the alpha particles will come in. Both of them are emitted by the corona during a particular moment of the existence of the sun. That is much more of the corona. We also have another part of the sun that is referred to as the chromosphere. Chromosphere is actually the one that is in charge, is a layer that is made up of various gases. Also, you can also find here some of the gas such as hydrogen and helium. And it is actually approximately around 2,000 kilometers of thickness, this layer. It is approximately 2,000 kilometers thick, and in this layer the energy continues to be transported. In this layer of the chromosphere, you'll find that the energy is transported, energy is transferred through what we call radiation. Actually, this is the process by which the sun propagates its heat energy into the outer space, so as this energy reaches the planet sun. And because of the radiation, the hydrogen atoms sometimes absorbs the energy from another layer that is referred to as the photosphere. Actually, the photosphere is also referred to as the surface of the sun. This one is actually coming after the first layer of the surface of the sun, and then we'll have what we call the photosphere. The photosphere, it is completely made up of also sometimes gases, and this one is actually thin and comprises of the circular disk. It is comprises of what we call the circular disk. This is the one that is the disk that we are able to see it in the sky. It is the photosphere of the sun that gives the sun its circular disk, that we are able to see it in the sky. And that one, you only observe it through the filtered telescope. Do not make an attempt of observing the sun through the naked eye. You may go blind. That is much more when the astronomers uses a very important telescope that is filtering out other radiations, and then they are able to identify this layer that is referred to as the photosphere. And then when you go also there is also a thin layer that is referred to as the radiation zone. And as it is just radiation zone, it is in the radiation zone that we'll find that it is a region where most of the heat energy and light energy are propagated through, or they originate in the radiation zones, and they are transferred in a slow way as they move into the photosphere, so that the photosphere ignite the chromosphere, and that energy is propagated through various radiation or through various waves that are emitted. And then the last one is referred to as the convention. The convection zone is also part of it, but although this bring us to these three distinct layers, but still they make just one part. Convection zone is a zone that involves actually the boiling point, just like it makes most of the heat that is produced in a manner of a boiling like convectional liquid. Therefore, you'll find that when some layers are, especially the radiation zones, they sink, and when the heat energy becomes increased, they also rise up. Therefore, as they go to the photosphere, you'll find that the circular disk is now able to propagate the radiations or those wavelengths that are emitted, and then they go to affect the chromosphere in the form of radiation, so that they can now be transferred into the space. This will bring us simply to find out a very simple structure of the sun that we will be able to look at it shortly, and as we look at it very shortly, then we'll have been able to have summarized this structure. It takes a shape that looks as this way, and then you'll find out that there are different ways of representing the sun. We'll be able to have found out that this is the general part that shows specifically three basic layers. And when you look at the sun, you will find that there are various layers that are found here. On just the surface of the sun, you will find this very important layer that is referred to as the corona. The corona is the outermost layer of the sun. It is the one that emits various wavelengths in a different direction. Actually, when we are able to look at it, and then it is followed by another layer that is made up of the three distinct parts. That is the chromosphere. When we look at it, very, very important. We call it the chromosphere. This layer is actually very thin. It should not mix you up with the layer of the structure of the earth, but this is a longitudinal incision we just want to look at it. And then this is where there is a photosphere. These outer parts, this is the photosphere. This layer is the photosphere, and then this one is the corona. And then you'll find that this one marks the chromosphere, and then the middle part of it is referred to as the core. And it's actually, when you look at in the core, you'll be able to have identified other structures such as the radiation zone and the convection zones. These ones are found, they are just found approximately in between the core and the chromosphere. Just there are two layers here that are the radiation zones and the convection zones on longitudinal perspective. But now when you look very closer to the sun, this is a simple structure of a ball of glowing gases that is referred to as the sun. But now we will be able to look at it deeper in the next, or in the actually in the next step of our lesson, so that we are able to understand much more clear and better. When we look at it very carefully, remember there will be a representation of it. This ball of glowing gases, the ball of glowing gases, where there is what we call nuclear fission, where there is nuclear fission or a fusion, then the nuclear fission reacts so as to give out energy in a different direction. And this energy from the core, now they are propagated to various layers of the sun in various parts, actually, and in different direction. Therefore, this will bring us to understanding that as long as there is radioactivity and nuclear fission, this is the one that sustains the glowing of the sun to give us actually the radiant heat and light energy that glows into the space. And that is why that energy is very much important in form of the radiation. This brings us to be able to find out and understand the idea about the solar system. That is much more about the sun. When we look at the solar system, the solar system, just from the understanding, solar system comprises of the sun and the planets planets and also some other heavenly bodies revolving around the sun. This is the modern development of the solar system. But the idea about the solar system has changed since the beginning, or the ancient, especially from the early Egyptians and the Mesopotamians. They believed that the earth was just a universe that is static there. But the early Greeks came up with the ideas to explain about the movement in the sky. This movement has been about the idea bringing us closer to the solar system. For example, around 350 BC, there is a scientist who is renowned as Aristotle, and other philosophers They're the one who proposed that the Earth is actually motionless. Remember, they are talking about planets. These people are discussing about the planet in the solar system. But they did not exactly understand the solar system. That is why their idea has been borrowed. And therefore, developing this idea of Aristotle, more research have been to take under the period as it unraveled itself. They also suggested that the sun, moon, and the planets and other stars are actually in a fixed sphere and they move around the earth. Look at that. That is the development of Aristotle. And coming to around 2 AD, another scientist referred to as Ptolemy, who is an Alexandrian astronomer. He came up with a very complex explanation to describe the motion of the planet. And then he described the earth being at the center and the moon, the sun, and the planets. He is the one who described about he described the earth to have been found at the center. Look at this development. The earth is found at the center. That means that the moon and other planets goes around the earth in what we call in a motion that is referred to as, or that is moving in a motion around the circles that he called them the epicycles. He referred to them as the epicycles. That is the movement over which the sun, the moon, and the planets were going around the earth in epicycles. Those are the circles that he postulated. Let's see the development of this idea. But now in the 10th century, that is in the 10th century, Albertani, who is also an astronomer, Albertani, an astronomer, determined, who was an astronomer and a determined mathematician. He was found in Iraq. He determined the length of the year and the seasons and the solar eclipses. This one, he dealt with the length of the year and what we call the solar eclipses. He's the one who discovered the solar eclipses. And then coming back to 11th century, these are still the development of the idea of the solar system. The Persian astronomer who was called Hayam. This is how the name is written, who is also an astronomer and a poet. He accurately calculated the length of the year in his solar calendar. He came up with the accurate length of the year in his book that is called the solar calendar. That is the idea he came up with. And having come up with this idea, there is still another idea developing from Hayam. We are able to look into another person that is in 16th century. Around 16th century, there was a scientist that was referred to as Copernicus. Copernicus was also a very renowned and a polished astronomer. He proposed that the planets are moving around the sun in a system of cycles. What did Copernicus propose? He proposed that the planets moves around the sun. This is now another idea of Copernicus, who was a Polish astronomer. He came up with this discovery in 16th century. And then another development continued in 17th century. An Italian scientist who was referred to as Galileo Galilei. Galileo, he supported Copernicus' idea by saying that planets moves around the sun, and he also discovered, he supported the idea of the planets around the sun, and he discovered the 4 satellites, and these satellites are referred to as the moon. He discovered the 4 satellites. You remember Galileo is the one who is the father of the telescope, who persisted into the space and the sky and found out that there are 4 satellites, the moons that are found there. And then another development continued by Kepler, who was a German astronomer. He proved that the planets travel in ellipses. He's the one now who came out with the idea that planets travels in ellipses. This is an oval path that we are going to look at. It is actually the modern orbit. Therefore, you will find that he is the one who modified Copernicus' idea and put various laws to describe all the motions of the planets in a system that is referred to as the orbit. So far, we have adopted the Copernicus model, who proposed that the sun is at the center of the solar system. Now bringing and developing an idea that we have moved from an ancient development of information, and various discovery has been done. So far, his idea, actually the Copernicus idea, has been developed into the modern development of today. And all these models have been improved into the modern models that shows that planets are following their special path that we refer to them as the orbit. Therefore, from there, we'll find that it is Copernicus' idea or model of the solar system that we'll be able to adopt. We leave away the Ptolemies. Remember, Ptolemy's idea was suggesting that the planets, the moon, and the sun. Okay, he suggested that the moon, the sun, and the other heavenly bodies are going around the earth, which has been proven today, disapproved by Copernicus. And therefore, as a Polish scientist, we have also been able to follow this, and actually we have to look at the orbits. These are paths which have been followed by other heavenly bodies. Now, the other heavenly bodies will be able to have found out that we have planets, we also have stars are a part of the heavenly body, and then we have the moon. The moon is part of the heavenly body, and others such as comets and asteroids. All those are part of the heavenly body. They follow the path that is referred to as orbit. As they travel, you'll be able to discover that they are revolving around the sun. They revolve around the sun. Now, bearing in mind that Copernicus, if he come today, he will be able to still find out we are developing on his model. Therefore, all planets have their orbits at which they revolve around the sun. And that model has given us an adoption that these have been adopted in various segments. When we look at it, they have been arranged in a series of orbits, which looks like the circular aspects in this manner as we develop them. And then here we have the sun, and then we have a planet referred to as Mercury, and then we have another planet here referred to as Venus, and then the third planet is the Earth. After the Earth we have the Mars, and then after planet Mars we have Jupiter, which is slightly bigger, Jupiter. And then from planet Jupiter we have Saturn. I will just denote it using S. And then after Saturn we have Uranus and Neptune. After Saturn, we have another slightly small planet. It is slightly smaller. That is referred to as Uranus. I will denote it, it is E. And then lastly, we'll have, this is Neptune, denoted by letter N. Remember, also he had included another planet that was referred to as Pluto. But this one has been regarded as the dwarf planet because it has its own orbit that is not attached actually in this aspect. Therefore, it is disregarded as a dwarf planet. Therefore, when we look at this model, is the one, this is now the orbit. Every planet has its own path that is referred to as the orbit, and they travel around the sun in an anti-clockwise direction. You'll find that all these, they move in that, except a few of the planets that moves in a clockwise manner, as we'll be able to find out. Therefore, this is a model of the orbit of the solar system. I'm just using letters to denote because of the space cannot be able to accommodate most of our letters here. Then from the sun, that is Copernicus model, from the sun we have Mercury, then we have Venus, we have the Earth, and then we have Mars, we have Jupiter, we have Saturn, we have Uranus, and Neptune. This is how they are found in the solar system. And this is what we refer to as the modern solar system. Now, but as we are going to look at the greater part of this, we'll be able to find out that there is a period and a distance that we will be able to distinguish these planets from each other. There is a distinction of these planets from each other. That is why when we look at the planet with their various characteristics, then we'll be able to have found out that that there are various distance that are different, and the revolutions, and also the number of satellites. That is especially where we looked at. Then we are going to look at this planet in a tabular form, so that we are going to summarize. We are going to summarize them in this format. I'll be able to begin with the first planet from the Sun, that is Mercury. And then we have Venus. And then we have the Earth. And then we have, after the Earth, we have Mars. After Mars, we have Jupiter. After Jupiter, we have Saturn. And then we have Uranus. And then we also have Neptune. When we look at these planets, we'll be able to have found their distance from the Sun. What is their distance from the Sun? And also we find out the days this planet take in revolution, or how long do they take in revolution. And then actually we look at the satellite that they have. Do they have satellites? For example, now when we look at this planet in this tabular state, and then we are going to find out that there is a period each of the planet is going to take to revolve around the Sun. Now, let us look at Mercury as our first planet. Mercury takes a distance that is approximately 58 kilometers. That is million kilometers away from the Sun. It is actually 58 million kilometers away from the Sun. And it takes around 88 Earth days to revolve around the sun, and Mercury has no satellite. Mercury does not have satellite. And as a result of that, we are able to find out that it takes 58 million kilometers away from the sun. That is the distance from the sun. And then it takes 88 Earth days to revolve around the sun. Actually, we have also been able to find out that Mercury does not have any satellite. Therefore, it is the first planet after the sun. Then we move to the second planet, that is Venus. Venus has a distance of around 108 million kilometers. That is away from the sun. And it is the second planet from the sun. It is very small, and sometimes it is also referred to as the twin planet because it has similar characteristic with the third planet, that is the Earth. And this planet can easily be seen by our naked eyes, especially in the southern part of the hemisphere. It can easily be seen as the evening star. Some books call it the evening stars, and others morning star. And it takes around 225 other days to revolve around the sun. It has no satellite. And then we have to move to the third planet, planet Earth. Planet Earth takes approximately, that is 149.6 million kilometers away from the sun, which is, when you round it off, it's 150 million kilometers that is away from the sun. And it takes around 365.25 days to make a complete revolution. That is one revolution around the sun. Planet Earth is the only planet so far we have discovered that sustains life, and it is known to have one satellite, that is the moon. In the previous lesson, we were able to look at the various phases of the moon. Therefore, they are found in the space of planet Earth. This planet is the one that supports life, and that is why we are very much important to go into details discovering about planet Earth, both the structure of the Earth and the structure of the sun, and how they are related with, that is, the life that is found on Earth. And that becomes more important. We also have another planet that is referred to as Mars. Mars is the fourth planet after the Earth. It takes around, it has actually around 228 million kilometers. They are 1 million kilometers away from the sun. Although it is held on its orbit by the gravitational pull of the sun that keeps holding it in orbit. And it also takes, that is 687 days to make a complete revolution. Remember, these are the other days. We are using other days at least to count the number of days that we can be able to find planet Mars revolving around the sun. And planet Mars has no satellite, therefore there is no any satellite that has been discovered there. Planet Mars is also referred to as the red planet because it bears some characteristic of having red elements that are in it, and actually its surface is rocky, but it does not have any oxygen. We do not have life supporting life that is found in planet Earth. Only life can be supported on planet Earth, not on Mars. Therefore, we go to Jupiter as another planet after Mars in that order. You'll find that Jupiter is placed at a distance of 778 million kilometers away from the sun. And it actually takes a longer distance. It takes around 12 Earth years to make a complete revolution around the sun. Jupiter is also have been discovered that it has approximately 16 satellites. Those are the number of satellites that have been discovered in the planet that is referred to as Jupiter. Now, in planet Jupiter, there is something that is very unique with the Jupiter. It has a very unique ring on its center part of it. And when you look at it very closely or separately from other, you will find that it is the largest planet among the solar system that we have. And then from there, it takes around 12 Earth years to make a complete revolution around the sun. And it has been discovered that it is having approximately 16 numbers of satellites. From Jupiter, we can move to the other planet that is referred to as Saturn. Saturn has 1,427 million kilometers away from the sun. And how long does it take? It takes around 29 and a half years to make a complete revolution. Look at it. It is quite interesting. This is now, when you compare Saturn and Jupiter, you'll find that Saturn is relatively smaller compared to Jupiter, actually in size, when you look at it in the space. Then it also takes around 29 and a half years. Those are Earth years. It has also been discovered that Saturn has approximately 14 number of satellites, because the planet that has been known to have highest number of satellites is Jupiter, and then followed by Saturn, taking around 29 and a half years to make a revolution. Then as you move to the next, that is the seventh planet. The seventh planet is Uranus, that it takes around 2,870 million kilometers away from the sun. This one is actually the 7th planet that is also relatively smaller compared to Saturn. And it takes around 84 Earth years. It takes around 84 Earth years to make a complete revolution. That is only one revolution. And it is also been found out that it has got approximately 8 number of satellites which have been discovered that are revolving around Uranus. And then we move to the 8th planet, and this 8th planet is called Neptune. Neptune becomes the 8th planet. Neptune becomes the 8th planet, is actually the 8th planet after Uranus in the order. It takes around 4,497, that is million kilometers. That is the distance it has. When you approximate, the distance is 4,497 million kilometers away from the sun. And it makes a complete revolution, taking around 165 years to make one complete revolution. It has also been discovered that it has 8 numbers of satellites. Therefore, this is the order of our solar system that we have summarized with their distances, actually approximate distance from the sun, and the number of days or the number of years a planet takes and goes around a sun. That is to make a complete revolution. And perhaps a more sensitive also aspect, does it have a satellite or does not have? Therefore, beginning from Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and also Neptune, we are also able to find out various distances that this planet takes, or these planets are placed in different orbits away from the sun. Therefore, all these planets, they revolve around the sun. And as they revolve around the sun, they are placed in a different orbit with different distances actually from the sun. And they also have a number of days or years they have to take to complete one revolution. That is to make a complete of one revolution, and various, either it can be having a satellite or do not have. Therefore, this is our model of a summarized table or summarized data of the solar system, having this more details. With those very few remarks, I hope we have been able to discover about the solar system and the sun. Thank you.